Hello friends, welcome back to my channel Chemistry with DB. In this video I'm going to explain as to why do group 6 elements, for example oxygen, have a lower first inertia energy than the group 5, for example nitrogen. Now you know that the general trend in a period for the first inertia energy is increasing. That means as we go along a period, the ionization and first inertia energy increases. The reasons for these are, the first reason is that the atomic radius decreases. The size of the atom decreases as we go across a period because of the number of electrons increasing, number of protons increasing. Now, the second reason is that the shielding stays the same for all elements in a period because the number of shells remain the same. The third point here to consider is as the number of protons increase successively because of the atomic number, the attraction from the nucleus increases. Therefore, sum total of all these three factors is that it becomes more difficult because of the greater nuclear attraction to remove the first electron from the outermost shell. This is why the first inertia energy increases across a period. Now, what happens when we look at a group size 6 vis-a-vis group 5? For example, oxygen versus nitrogen. Now, in order to understand that, we'll have to look at the electron configuration for both. Now, oxygen has got 8 electrons and the outermost electron, the first electron, goes from a 2p4. Now, you know, in the p orbital, the electrons occupy singly first each orbital. So, these 3 electrons go in this manner and then pairing happens. So, the 4th electron then forms a paired orbital in case of oxygen. On the other hand, in case of nitrogen, these 3 electrons occupy each of these 3 p orbitals. So that means here we have an unpaired p orbital from which the first electron will have to go. As a result of this, in case of oxygen, there is a greater electron-electron repulsion, because when there are 2 electrons present in an orbital, they are going to repel each other. So it would become easier to be lost. No such thing is present in case of nitrogen, and therefore oxygen first inertia energy is going to be lower than that of nitrogen because the electron is easier to be lost. Similar trend is shown in the period third, wherein group 6 element sulfur also shows a lower first inertia energy than the group 5 phosphorus. So again we'll have to look at the electron configuration. So sulfur, the first electron is going from a 3p4. So 3p4 means the electron is being removed from a paired orbital. Greater electron-electron repulsion makes it easier to be lost. As against this, in case of phosphorus, the first electron is removed from a unpaired p orbital and therefore no such electron-electron repulsion extra will be there. So this is the reason that less energy is needed to remove the first electron from sulfur. This is why the first inertia energy for sulfur is going to be lower than the first inertia energy for phosphorus. I hope this explanation was easy for you to understand, and if you like this video then please like, share and subscribe. And for any lesson inquiries you can always get in touch with me on chemistrywithdb@gmail.com. And thanks for watching, and I look forward to see you on my next video. Thank you so much. Bye bye. Take care.